Hello, everyone. Today we're going to cover Chapter 6, Supplement, Part B. Last time we talked about how to construct the X-bar chart. Today we're going to talk about how to use the chart to monitor the process. Let's look at some patterns. This is an X-bar chart. On the X-axis, you have the sample number. On the Y-axis, you have the sample mean. And we plot the sample mean for each sample. Now, if the sample means look like this, what decision should he make? Should he conclude the process is in control or out of control? Do you see this sample mean that's above the upper control limit? And this is also lower than the lower control limit. So if one or more sample means is outside the limit, then we need to conclude the process is out of control. There's something wrong in the process. We need to take action to fix the problem. Let's look at another pattern. All the sample means are within the limits. So we conclude the process is in control. But I'm a little concerned about the trend. It looks like the sample means are going down. Who knows what's going to happen in the next few hours? So what should you do? Watch it carefully. Monitor closely. Let's look at another pattern. All the sample means are within the limits. So you conclude the process is in control. But I'm a little concerned about the way these values are fluctuating. They are fluctuating more and more. So who knows what's going to happen in the next few hours? They may go beyond the limits. So what should we do? We should keep watching, monitor closely. This is another pattern. All the sample means are within the limits. So we conclude the process is in control. Everything looks normal. There's no trend. We see the same level of fluctuation over time, so we don't need to take any action. Now, the next type of control chart is the R chart. Again, we have two key questions. How can we construct the chart? And how can we use the chart to decide whether the process is in control or not? Let's take an example. A fire department is concerned with its ambulance response times measured in minutes. The target average response time is 15 minutes. Data from 5 samples appear in the accompanying table. A, compute the lower and upper control limits of the R chart. In the R chart, we're going to monitor the variability of the observations. So we're going to monitor the level of fluctuation. So we're going to compute the sample range for each sample, and we're going to plot them. So let's compute the sample range. The sample range is the largest value within a sample minus the smallest value within a sample. So that's going to be 0.9. And here are the rest of the sample ranges. And we're going to average them and get 2.46. We're going to call it X bar. And to compute the upper control limit and the lower control limit, we're going to use these formulas. We know where to find R bar right here. Now we need to find D4 and D3. Where can you find D4 and D3? In this table, D3 is right here, D4 is right here, and they depend on the size of the sample. What's the sample size of this example? That's the number of observations within a sample, which is 3. So when the sample size is 3, D3 is 0 and D4 is 2.575. So D3 is 0, D4 is 2.575. So the upper control limit is 6.33 and the lower control limit is 0. Now let's draw the X-bar chart. On the x-axis, you have the sample number 6, 7, 8, 9. On the y-axis, you have the sample range. We have two horizontal lines. The upper control limit is 6.33 and the lower control limit is 0. Part B, the fire department kept collecting samples as follows. Is the process in control? This is sample number 6, 7, 8. And in each sample, we collected 3 observations. And we want to plot these samples in the X-bar chart and see if the process is in control. Should we plot these numbers in the R chart? Remember, the y-axis of the R chart is the sample range. So we need to compute the sample range for each sample and plot them. What's the sample range of sample number 6? The largest value minus the smallest value, which is 2.4. What's the sample range of the sample number 7? The largest value minus the smallest value, 1.9. Next, what's the sample range for sample number 8? The largest value minus the smallest value, 3.3. Okay. And then we're going to plot this on the X-bar chart. And the sample number is 6, the sample range is 2.4, 6 and 2.4, and 7 and 1.9, 7 and 1.9, and 8 and 3.3, 8 and 3.3. Now we can make a conclusion. Is this process in control or out of control? Since all the sample ranges are within the limits, we can say the process is in control. Now, this is everything we have for this part. I'll see you next time.